Hi there, this is Mr. Jansen, and today we're talking about common and natural logarithms. In order to understand these, the first thing we need to define is in terms of the natural logarithms, is the natural number e. The natural number e is used to express a specific number, just like we have pi we think of as a number, and it's an irrational number that's never ending, never repeating. E is very similar to that in that it's a rational number, and it's a letter that represents a number. The letter E, or the number E, comes from this. It's when we take 1 plus 1 over n raised to the n power as it approaches infinity. And really, you're not going to be quizzed on any of that, but that's your kind of preview to pre-calc and calculus in terms of limits as these things shoot off to infinity, these two opposing forces. What we end up with is this number, and this is the approximate form of E. It's about 2.718. Again, it's a never-ending decimal, so we can't write out the whole thing just like pi. We tend to abbreviate it. All right, so now that we understand E and we know where that comes from, again, it's just a number represented by a letter. We're going to plug a couple of these into the calculator, so keep this in mind. When we look at our calculator here, the number E is actually on our calculator. If we use E on the calculator, it knows what we're talking about. In fact, there's a special button here if you hit second, and there's an E to the X button right down here. And if you type in that E raised to a power and I punch in the 2, it'll know to use E as the number E and not as a letter. So we're just going to plug this in. And again, this is just us understanding that this is a number. And I'll round it to 3 decimal places. That looks good. Okay. The next one, threw 2 irrational numbers at you. Let's see, e raised to a power, and this is e raised to the pi power. So now I'm using the e button and the pi button on my calculator. Again, the calculator knows what these mean. So I get 23.141 is what it rounds to. For this third one, we have e raised to the 2e. Again, I'm going to use the E button here, e raised to the power of 2 times. And now this can be a little bit tricky. You can go through the calculator's modes and find the E button or the lowercase e in here, and it'll recognize it that way. But the easiest way to do it is just to use this e raised to a power button again. And if we want just plain old e, that's e to the first power. Okay, so now I close the parentheses for the e to the first, and now I close the parentheses for the entire exponent. So now what I have is e raised to the power of 2 times e to the first, which is what this really is. And when I hit enter, I get 229.652. All right, so I kept them all as 3 decimal places. And again, it's just understanding that that value represents a number, and that value is also on our calculators. When we talk about the common logarithm is just a logarithm of base 10. And we kind of write it without the 10. We assume that there's a 10 there. All right, so the common logarithm is just log base 10. So in other words, log base 10 of a, which is what we have right here, we would literally just write as log of a. All right, and you've probably seen this one on your calculator. This is one of the logarithms that's on your calculator. It's log base 10. Okay, so if we don't write a base in there, we assume that it's 10. On the flip side of that, the natural logarithm, this is just the logarithm with log base e. So in other words, log base e of a, that's our natural logarithm, and we write it like this. Okay, we use this abbreviation ln for the natural logarithm. And the reason it's ln instead of nl is because this comes from a different language. It comes from the Latin for natural log. And of course, in other languages, they put the adjectives and the noun in a different order. Okay, so that's why it's ln instead of nl. Okay, so again, log base e of a is written just as the natural log, ln of a. Okay, so the natural log. And again, this is really just a job for my calculator here. This is saying that we want log base 10. And again, that's this regular old logarithm button on our calculator. So it's log of 7. That's 0.845. The next one, we've got the log of 5. So that's 0.699. Again, I'm going to 2 decimal places. And then this one, I don't even need to plug this into my calculator. Log base 10 of 10, that's going to be 1 because the base and the of the logarithm and the base of the exponential part are the same. Okay? And that's it. That's all we have to do for those. For these last couple, now we're just using the natural log, which is this button down here, the ln button. So the natural log of 6, I punch it in. It's 1.792. The natural log of 4 is 1.386. And then the natural log of e, I don't even need to punch in, but again, if I wanted to, I would just use the e to the first button is the easiest way to go, and then just make sure I have parentheses to match up. I know this is going to be 1 because the base of the logarithm base of the exponential function match one another. And of course the calculator agrees. Okay? So again, these are the two logarithms that are on our calculator. All right? And the reason that's important, the reason we're going to use these is because logarithms, any logarithm can be written in this form. Okay? So, using different bases, if I have log base a of m, what I can use is this change of base formula, which allows me to rewrite this using any logarithm I want. Okay, so log base a of m equals log base b of m over log base b of a. In other words, I do the logarithm of what was inside here over the logarithm of the original base. And the question here is, what's b? Okay, b is what? B is whatever I want it to be. I could choose any base that I wanted. Okay, I could choose base 3. So I could rewrite this as log base 3 of m over log base 3 of a. Or I could use a 20. Oh, my board is freaking out. Or I could use a 20, log base 20 of m over log base 20 of a. Okay? But obviously, none of those logarithms help me, so I have to choose a logarithm that's going to be useful. So the recommendation here is to choose either the common log, because it's on our calculators, or the natural log. All right, so even though the change of base formula, I can use any base I want, I'm going to choose either the common log or the natural log because those are the two that are on my calculator. All right, so for this guy right here, and again, this is how we're going to evaluate these logarithms from here on out. I'm going to use my change of base formula. So I can either do there we go, the common log of 3 over the common log of 2, or I could do the natural log of 3 over the natural log of 2. And either one of these is going to give me the same answer if I jump back over to my calculator. So this one, again, common log of 3 divided by the common log of 2. Gives me 1.585. If I do the same thing with the natural log instead, natural log of 3 divided by the natural log of 2. Hey, look at that. 1.585. Okay, so it doesn't matter which of these you use. They'll both give you the same answer. And that's how our change of base formula works. I can change it to any base, but there's two bases that make sense. Okay? For me personally, I prefer one of these over the other. I prefer to use the natural log. And the reason I use the natural log is because it's one less letter to write. So over the course of your mathematics career, you're going to end up writing thousands of less letters because you used ln instead of log. Okay, so for this one, again, the common log and the natural log, you could use either one. But I'm going to use the natural log. So this first one I'm going to change to the natural log of 6 over the natural log of 4. And then times, this one I'm going to change to the natural log of 2 over the natural log of 6. And now this is where my my knowledge of fractions comes in handy because I can cross reduce. The natural log of 6 is going to cancel out. So I'm just going to be left with the natural log of 2 over the natural log of 4. And that I can just plug into my calculator. The natural log of 2 divided by the natural log of 4, and it gives me 1/2, 0.5. All right, and that is a coincidence that 2 divided by 4 is 1/2, and that I also got a 1/2 for the logarithm. Okay, that will not happen every time. If I look at this one, again, I'm just going to rewrite it. I'm going to use my change of base. So natural log of 2 over the natural log of 5. I take what's inside the logarithm over the original base. And then I just plug it into my calculator. Natural log of 2 divided by the natural log of 5. And I get 0.431. The next one, again, natural log of 4 divided by the natural log of 2. So natural log of 4 divided by the natural log of 2. That's going to equal 2. And again, the fact that the numbers divided, it didn't work over here with the 2 over 5, so keep that in mind. It's just the nature of 4 and 2 at work. This one, natural log of 2 over the natural log of 6. So you see how simple it is to use our change of base formula. And this is why they didn't include so many bases on the calculator, because you really don't need them. You really only need one base, and you can do almost every problem. All right, as long as we do our change of base formula. This one, natural log of e over the natural log of 3. And I can simplify that a little bit by hand. Natural log of e, well, that's just 1. So I've got 1 divided by the natural log of 3. So 1 divided by the natural log of 3. 0.910. Last two here. This one, I'm going to use the common log. I know I use the natural log for every single one of them, but this one I'm going to use the common log. And here's why, because I see a 10 in there. And by using the common log, I can do a little bit in my head. I know that that's going to be 1 over the common log of 5. And that's just a little less I have to punch in my calculator. 1 divided by the common log of 5. And I get 1.43. And once again, you don't need to use the common log there. You could have used the natural log. I'm going to go back to my natural log again. E over the natural log of 4. So that's 1 over the natural log of 4. And I just plug it in. 1 divided by the natural log of 4. Okay, so this is how common and natural logarithms are going to be used. Again, these are the ones that are on our calculators. So these are the ones that we're going to want to change each of our bases to. And that's it. Okay, that's all there is to it. So that's common to natural logarithms at a real quick, brief summary. But we're going to use that a lot for our change of base formula and evaluating these. Okay.